We will be graphing parallel lines, which means these are lines that never intersect each other. And there's something special about the way their equation looks like, which is what we're going to discuss right now. Then we have perpendicular lines. Now, these are lines that do intersect, but they intersect at a very special angle. They're going to form a 90-degree angle. So when perpendicular lines intersect, they form four right angles. So we're going to go ahead and look at these equations here, and we're going to go ahead and graph them, and we're going to determine if these lines are parallel or perpendicular. And then you're going to notice a pattern on how to determine whether they're parallel or perpendicular without having to graph them. Okay, so all these equations are in this form. This is called slope-intercept form, which is y equals mx plus b. So our graph, we always started with the b part of it, which is your y-intercept. So the first one happens to be 4. So on the y-axis, we're going to place our first point on 4. The way we get the other points is by looking at our slope. Our slope will tell us how to move from the starting point to get the rest of the points. So in this case, our slope is 2. So in order for us to move, we're going to move up and down, up or down, and right or left. So since our slope is 2, we put it over 1, we move twice up and 1 to the right. Or we can do the opposite of it. We can go down twice and we can go to the left once to continue getting more points on the other side of our starting point. Then we'll get as many as we can. The more points you have, the more accurate your line will be. Unless you're using a ruler, then it should be accurate without having to get all the points possible on our coordinate plane shown here. Don't forget your lines at the end, since it's a line, is continuous. And we're going to apply the same strategy for the second equation. So our starting point for the second one is -6. Our slope is also 2, so we'll follow the same pattern as the same line. So as you guys can tell here, these lines will be parallel lines. They're never going to intersect, no matter how many points you plot. All right, same strategy for the other one. Starting point is 6. Our slope here, it's already in fraction form. So you can put the negative either on the numerator or you can put it on the denominator. But don't put it on both, because if you put it on both, then you're going to turn your slope into a positive slope. And this one is a negative slope. So the line should be decreasing. So either we go down once to the right 3, or we go up once to the left 3. starting location for the second equation is -4. And our slope is 3, so we'll put it over 1 so that we can get our movement left or right. So up 3, right once. Or do the opposite, go down 3 and go to the left once. Remember, when you're doing the opposite, you have to do the opposite of both the change in y and the change in x. And then once we get all the possible points, we go ahead and connect them. And then this ones, you can see that they're going to intersect and they form a 90-degree angle when they do. So these are perpendicular lines. And hopefully you're noticing a pattern in the equations that reveal whether the lines are perpendicular or the lines are parallel even before you start graphing them. So pay attention to what a pattern that you see here. All right, for the second one, we'll get you guys just started. So our slope here, we don't see a number before our x. Our slope means that it's going to be 1. So when you are trying to see how you're going to move, just put the 1 over 1 to make it a fraction. And then we'll get our movement. So up 1 to the right 1 or down 1 to the left 1. And this is how we graph equations in this form and how we determine if they're parallel or perpendicular.